25 centimetres cubed of hydrochloric acid of concentration 1 mole per decimetre cubed reacts with 18 centimetres cubed of sodium hydroxide solution. Calculate the concentration of the sodium hydroxide solution to 3 significant figures. The equation for the reaction is below, and we can see that it is a balanced equation. So to tackle this question, we need to know how to calculate the concentration, and there are 2 equations that we've learnt this week. The first one is that the concentration, I'm just writing that in shorthand, equals the mass over the volume. And remember that mass needs to be in grams and the volume needs to be in decimetres cubed. And the second one that we've done is that the concentration equals the number of moles divided by the volume. And again, the volume needs to be in decimetres cubed. Okay, so if we have a look in our question, we can see that we have a volume of hydrochloric acid and a concentration in moles per decimetres cubed. And then we also have a volume of sodium hydroxide. So that means we have no masses, in which case we will not be using this equation, we will only be using this one here. So the first thing we need to do then is to calculate the number of moles of hydrochloric acid. And that's because if we want to calculate the concentration of sodium hydroxide, we need the number of moles of sodium hydroxide. At the moment we only have the volume. So to calculate the number of moles of sodium hydroxide, we need the number of moles of hydrochloric acid, and then we can use our balanced equation to calculate the number of moles of sodium hydroxide. So the number of moles of hydrochloric acid, we need to rearrange this equation over here, and if we rearrange it, we get that the moles is equal to the concentration times the volume. And if we have a look at hydrochloric acid, it's got a volume of 25 centimetres cubed. Remember, it always needs to be in decimetres cubed, so we divide by 1,000, and that gives us 0.025 decimetres cubed, and a concentration of 1. So that means the number of moles of hydrochloric acid is 0.025. And then if we look at our balanced equation, we can see the ratio of hydrochloric acid to sodium hydroxide is a 1-to-1 ratio. So that means if we've got 0.025 moles of hydrochloric acid, we must also have 0.025 moles of sodium hydroxide. So to calculate the concentration of sodium hydroxide, we just use this equation here, and we've got the number of moles, which is equal to 0.025 divided by the volume. The volume is 18 centimetres cubed, so again we need to divide by 1,000 to put that into decimetres cubed, which gives us 0.018. If you do that on the calculator, you will get an answer of 1.38 recurring. Remember, we want it to 3 significant figures, so that makes 1.39 moles per decimetre cubed to 3 significant figures.